We're starting a new chapter, chapter 3 this week, polynomial and rational functions. This chapter is packed full of algebra, so if you are good at algebra and always liked algebra, you will love this chapter. We're looking at quadratic functions and models. Graphing quadratic functions using standard form, maximum and minimum values of quadratic functions, and modeling with quadratic functions. So a polynomial is a function that's defined by a polynomial expression. So that just means that you're going to have possibly a constant. This could be 1, and then a base to an exponent, and then another constant, and then the base to a smaller exponent. So some of these exponents might be 0 and they may not exist. So anyway, this looks more complicated than it actually is. All it's saying is that you have polynomial functions. It could look like x squared plus 1. And if it was plus 1, it would be plus 0x plus 1 if you looked at this form. Any polynomial. So how do you know it's a polynomial? There's no fraction exponents, and it's not a rational expression, meaning that it does not look like a fraction. So we're going to study quadratic functions. So we're looking at the ax squared plus bx plus c. And we need to take a look at this using standard form. Now this is where I'm going to go back and say, this is why you had to know completing the square. So if you're still having trouble with completing the square, you need to practice that because you will be using it throughout this chapter. Here we have the quadratic function. It is a parabola. A parabola will go up like this if the a in the front is bigger than 0. See, bigger than 0 here. So that's just telling you that it will go up. So it's concave up. If it was 0, then this whole thing wipes out and it's not a quadratic. So that's why neither one of these has the equal to underneath it, okay? And if it is less than 0, then it's concave down. HK, what is HK? We're saying this is wherever the vertex is. So the H is the X value, the K is the Y value. So in standard form, whenever you have minus H, then you're going to take the opposite sign, and that's where it's at on the X, plus K, you keep whatever sign that is, and that is where it's on the Y, and that gives you this vertex right here. Okay, so HK is the vertex. So we're going to express this in standard form. The coefficient is 2, it's not 1, so we have to factor the coefficient from the terms involving x before we can complete the square. Now this is what we went over in class before the exam, and then the exam also had a question on it where you had to factor a 2 out from the front. So let's take a look at this again. I have to take the 2 out because this term with x squared has to be 1, okay? So I have to factor that out of both of these. I don't worry about the 23 because it's going to be used for something else. So I just factor it out of both, and that's why we have the parentheses here. Now I'm going to take this middle 6. I'm going to divide it by 2. And then I'm going to take the whole thing and square it. And that will tell me what I need to use to complete my square. Once I do that, this completes the parentheses right here to be a binomial square. The square root of x squared is x. The square root of 9 is 3. Actually, I'll just go ahead and write that up here. We have 3 and we have x. And then if we multiply them together and double it, doubling means multiplying by 2, I will get 6x, which is what I have in the middle. Okay, so this is my test to make sure this is a binomial square. When in fact I do test it and see that it is a binomial square, then I'm going to take x, which was the first term squared. Whatever this sign is comes down. So minus 3. Quantity squared. So that's how it turns into the binomial square there. Now, this is not an equal to 0. This is equal to f of x. So I haven't moved my 23 on the other side. It just kind of hangs out over here. And what I have to realize is that if I am adding 9, which is will always be addition because it's a square. 3 squared is 9, negative 3 squared is 9. So it's always square, so it's always positive. I am actually taking 2 times that. You might remember from the last section we talked about this. 2 times 9. That's 18. So that means now I can't add it to both sides. I need to instead subtract it to this side. These two, since I added it here, I have to subtract it here to keep my equation equal. It's the same thing that I did before. In fact, if I decided to take the 23 and move it over with f of x, I could. I wouldn't suggest it for doing this because then you're going to have to move it back. But I could move my 23 over here and then just work with the other side. If in fact I did decide to do that, then I would be adding to both sides instead of adding and subtracting to one. The idea is that you have to keep the equation balanced. So if I'm going to add 18 to one side, then I would have to add it to the other side. But if I'm going to add it to one side and not add to the other side, then I have to subtract it because they have to cancel out. Okay? So make sure if you don't understand this, you ask me. So this is now 23 minus 19. So this is still going to be a positive 5. And I probably wrote too far down. It's probably going to come up and go over my numbers. So let's take a look. Yeah, so let me erase my mess here. And now you can see there's better. Okay. So I have 2 times x minus 3 quantity squared plus 5. Now, this is standard form. What does that mean? Well, the 2 is positive, so that means that my parabola is going to go up. And since I'm multiplying it by 2, you might remember that when I had my standard parabola, if it looks like this, multiplying it by 2 is going to make it a little bit steeper. So that might come in and look like this. And how would you estimate that? Well, you can plot a few points to help you is probably the best way of doing it. Okay, so now this is my HK. My HK is going to be a positive 3, because remember it was minus H. So it's positive 3. Actually, let me just put the 3 in there. And then plus K is my vertex of 5. So that means this whole parabola that I have over here in the red is going to go over 3 and up 5 and then be graphed. So let's take a look at that. I'll use green. And I'm not going to have it perfectly drawn to scale. I'm just giving you an idea. I would take the vertex, go over 3, up 5, and my vertex would now be here. So my parabola is going to go up like this. I just moved it over and up. Okay. So I'm sure the next graph will show you that. So again, taking the parabola, y equals x squared, shifting it to the right 3, stretching it by the factor of 2, which makes it steeper, and moving it upward 5. The vertex is 3, 5, and the parabola is opening upward. There it is, just like we did. Now their scale on this side's a little different than ours is all, but they're marking this as 5s here, so that's the way it looks. Now the y-intercept is always good to know, so you can just plug in 0 for x. Okay, so 0 for x to find the y-intercept. And that'll give you your y-intercept, okay? Which here is 23. And that's important to know because it also helps you to graph how steep it is. All right, how do we find our maximum and minimum values? If our parabola opens upward, like this first one, then I'm going to have a minimum value, and that's going to be my vertex, which is right here. Okay, so that'll be my minimum. If my graph opens downward, meaning that the number in the front would in fact then be negative, then I'm going to have a maximum, and my maximum is going to be right here at the vertex. So again, if our A value in the front is positive, I'm going to have a minimum value. If it's negative, I'm going to have a maximum value. Now we're going to look at another one. Now right away, let's talk about it a little bit. We have a quadratic 5x squared minus 30x plus 49. I notice right away that the first two terms, I'm going to factor a 5 out because there is a 5 in the front. Now keep in mind, just like the problem we practiced in class before the exam, it doesn't have to be divisible by 5. This might end up being a fraction here in the middle. The point is that you have to get the 5 factored out because you need a 1 in front of the x squared. So let's take a look. So as I said, you're going to factor the 5 out of the first two terms. And now I take my middle number, which is negative 6, and I divide it by 2. And then I'm going to square it. So really, since I'm squaring it, I didn't really have to even put the negative for the 6 because I'm going to square it and it's going to be positive. And I've said before that this is always going to be adding. Now this time, I'm adding 5 times 9, which is 45. So I have to also subtract 5 times 9, which is 45, because we're keeping it on the same side. So if we're taking it to both sides, we would add it to both sides, but we're keeping it on one side. So I have to add it over here, and then I subtract it here. Okay, so this again is a binomial square. How do I know it's a binomial square? Oh, I really hope by now you see it's a binomial square. This is squared. This is squared. What are the square roots? The square roots would be x and 3. So I have x here. I have 3 here. If I multiply those two together, I get 3x. And if I double it, I get my 6x, which is in the middle. This sign is the sign that we're going to use right here. So this becomes whatever these are, my x and my 3, x minus 3 with that sign squared. I have 5 here, and then I simplified over here, and now I have 4. So now taking a look at this, I need to understand that this is 3, 4 vertex. Because remember, it's minus h. So minus h means the h would just be 3. And k is 4. This tells me that it's pretty steep. It's going to be a pretty steep parabola. It's also going to open up because it is greater than 0. And here it is. Now we can find the y-intercept again by placing in 0 for x. So if we put in our f of 0, again, sorry, my writing I know is not the best when I do this. Okay, I'm going to place 0 into my function to find out what my y-intercept is. I will get 5 times 0 minus 3 is negative 3. And then I'm going to square that and then add 4. So if I square my negative 3, I will get 9, and 5 times 9 is 45. And then I'm going to add my 4 to it, and I will get 49. And that's why my y-intercept right here is 49. So that's a way that will help you when you are graphing. Now, we wanted to know what our maximum or minimum is. So since our a value is positive, it has a minimum, and that minimum is going to be 4 because my vertex is 3, 4. And how did I know it was a minimum? Because the coefficient on the x squared is positive. So it's concave up. So this has to be a minimum. And the y value of my vertex is going to be my minimum value. Okay, let's look at another one. Now I notice right away that in this problem that I'm going to have a negative x squared. So I'm going to have to factor that out first. And that should tell you that this is going to go concave down. So we're going to look at it in standard form, sketch it, and find the maximum because this is negative and we know we're going to have a maximum this time. So here we go. Factor out the negative, like I said. So I factor out the negative, I get this. Now I have to see what am I going to add and subtract to both sides to keep my equation balanced. Well, I take that negative 1 that's in front of the x, divide it by 2, and then I'm going to square that. So I'm going to add 1/4. But there's a negative in front of it, so that means I'm actually subtracting the 1/4. Since I'm actually subtracting the 1/4, then I'm going to add, and you don't have to do this part where you do minus a negative. You can just say, I'm going to subtract a 1/4 here, so I'll need to add a 1/4 here, which is what's going to happen when you take a negative of -1 times 1/4. And you might say, well, where did this -1 come from? Well, they're taking that from right here in front of the parentheses, the assumed 1 that's in front there. Okay, so we know that we have, again, the sign that's here is going to be the same sign, x minus 1/2 quantity squared. And when I do the math over here, 2 plus 1/4 will be 9/4, which is 2 1/4. So looking at that, what would my HK be? My HK is going to be 1/2 and 9/4. Now you might say, well, can we put a mixed number there? It's just really not common practice to put a mixed number when we're at this level. Usually it's an improper fraction, but it would be correct to put 2 1/4. Okay, as we said, we have the parabola, 1/2, 9/4. As an aid to sketch the graph, we find the intercepts. So we're going to throw our 0 into the equation and find out that we have an intercept of 2. And we can find the x-intercept since we know it's going to be above the x-axis and going down. It will hit the x-intercept. So let's see where it does that. And we can do that by setting the f of x value now equal to 0 and then factoring. So I set it equal to 0, multiply everything by -1 to get the negative out of the front. And factor, I will get this, set each one of those equal to 0, and I see that my y-intercepts are going to be 2, because that'll give me 0 here, and -1 will give me 0 here. So there are my x-intercepts. Here's my maximum value. Here is my y-intercept, and that gives me a nice picture of what my graph will look like. Again, since the coefficient on the x squared is negative, it has a max, and the maximum is going to be the y value of your vertex. So, expressing quadratic functions in standard form help us to sketch the graph as well as find its maximum or minimum value. We're interested in finding a maximum or minimum value when the formula is available for doing so. And this formula is obtained by completing the square for a general quadratic as follows. Now, this next slide gives you everything in formula form using A, B, and C. And it can look a little confusing. So if you just go back and remember what these values mean, then that might be very helpful. Okay, so here they're showing you if you factored an A out, then that will give you A on the outside, and whatever this B value is now going to be over A because you factored it out. Then you take this B over A and you divide it by 2, which will make it B over 2A. When I divide B over A by 2, I'm multiplying it by 1/2, so that gives me 2A. And then I'm going to square it. So when I square it, I will have my B squared on the top, my A squared on the bottom, and then my 2 now becomes a 4 because I'm squaring. Now I still have this C hanging out over here, so whatever I added to this side, I now have to take this times this and subtract it from this side to keep my equation balanced. After I do that, this is just showing you what the completing the square would look like when I change it to my binomial square. And I will see that I have my minimum value is going to be my negative B over 2A. My maximum value is going to be also negative B over 2A, depending on if A is greater than 0 or if A is less than 0. Okay, find the maximum value of each quadratic function. The reason that they showed you that whole set is that they're saying you don't have to go through and change it all to standard form to find a maximum or minimum. You can use the formula. So if you know that the maximum or minimum occurs at negative B over 2A, and A is equal to 1, and B is equal to 4, then you can shortcut it and plug those values in and find your maximum or minimum value. So here, this example, my maximum or minimum occurs at negative 2, and it is a minimum value because the A in front of the quadratic we were looking at is greater than 0. So my minimum is negative 4. So this is my X value that will go into the function to give me my maximum or minimum value. Now, quadratic function with A is negative 2 and B is 4. Plug everything in. I will get 1. Now notice that my A is negative 2. Since it is negative 2, that tells me that I am going to have a maximum value. And that maximum value will be what I get when I plug 1 into the function. And I'll have negative 3. All right, we're going to take a look a little bit at modeling with quadratic functions. Maximum and minimums are used in business, medical field, economics, so many different things, construction, and I mean, anything you want to look at where you want to know how much is the most that you have or what's the least amount that you can have, you're using maximum and minimums. So we're going to take a look at a couple of those. Here we want to see who gets the best gas mileage when traveling at a relatively modest speed. gas mileage M for a certain new car is functioned by this. So this is the formula that is given to you for our mileage given at a certain speed. So if my speed is between greater than or equal to 15 and less than or equal to 0, we want to find out where my maximum or minimum is. The function M is a quadratic. A is negative 1 over 28. So that immediately tells me that I'm going to be looking for a maximum. I'm not going to be looking for a minimum. So A is negative 28 tells me I'm looking for a max. Plug in my values and simplify, and I get 42. So now I need to plug that 42 value, which is my x value, into my equation, and I will get 32. So the car's best gas mileage is 32 miles a gallon when it's traveling at 42 miles an hour.